Okay, let's do an example of calculations with an equilibrium constant. Let's do number 38 on page 630. It reads like this: for the reaction N2 gas plus 3 chlorine gases yielding 2 nitrogen trichloride gases. I'm going to go ahead and write that equation. Okay, so we have the equation: nitrogen reacting with chlorine to produce nitrogen trichloride. It says an analysis of an equilibrium mixture is performed, and it's found that the concentration of nitrogen trichloride is 1.9 by 10 to the negative first, nitrogen is 1.4 by 10 to the negative third, and chlorine is 4.3 by 10 to the negative fourth molar. Calculate K for the reaction. Remember that they just use K instead of Keq for these problems. All right, so let's write the Keq expression. And remember, that's the products over the reactants, and they're raised to the power. So the product is this, so it's NCl3 square brackets and squared, take that 2 and put it there, divided by the stuff on the bottom, which, or stuff on the reactant side, which is N2 square brackets, 1 in front of that so we don't have to mess with it, and then chlorine gas, and that's got a 3 in front of it, so that's got to go here. Okay, so that's the equilibrium constant expression. You got to write that first. And that's what's different about these problems, is you have to write the actual equation you're going to use every time. But once we've done that, it's just a matter of plugging numbers into this now. They give you NCl3 is 1.9 by 10 to the minus first. And let's put the brackets around it, which takes care of the units for us. And on the bottom is nitrogen, which is 1.4 by 10 to the minus third, square brackets. And on the bottom also is 4.3 by 10 to the minus fourth, square brackets. And don't forget, and I already have forgotten, cube that and square that. All right, so then it's a matter of getting the calculator out. And be careful how you put this in the calculator, because there's a lot of times and dividing and making powers. So when you do this, the math, it comes out to be 3.2 by 10 to the 11th. We are not going to put any units on a Keq because the units just end up complicated. They'd be some bizarro mixture of molarities. All right, so there you go, an example of a Keq problem.